So hello everyone, this is the third video of my GFG POTD playlist, and the question is the kth largest element in a stream. So we are given a stream. Here stream is represented as an array, and also we have given an input that is k, and we have to find the kth largest element for each and every insertion of element in the stream. So here the stream represents within using an array. So actually, what that stream means here, I will explain you. Like if the array size is 1 2 3 4 5 6, so if the array size is 1 2 3 4 5 6, like 1 2 3 4 5 6, so one after another the element is inserted one after another. Like first element is inserted like 1, then 1 and 2, then 1 2 3, then 1 2 3 4, then 1 2 1, 2, 3, 4, 5, and so on. 1, 2, 3, 4, 5, 6. So in this fashion, the elements are inserted one after another. So you have to find that after each and every insertion, that what is the kth largest element. If the kth largest element doesn't exist, we have to return -1. Like for the first case, the first insertion of the element, that is 1, the array size or the stream size is less than k. So we can't find that kth largest element here. So we have to return -1. But in the second case also, the condition satisfies, which satisfies for the first case. The array size or the stream size is less than k. So we have to return -1 because we can't find the kth largest element. That is also true for the third case also, because the same condition happens in the third case, but some condition changes in the fourth case. So what the condition changes? If you see carefully that there is four element, we have to find the fourth largest element. So in the four elements, we can easily find the fourth largest element. So we can easily say the fourth largest element is 1. And uh, as per the above explanation, the second, like the fifth statement states will produce the fourth largest element as 2, and the last one will produce the fourth largest element as 3. So that's it, and the output should be like -1, -1, -1, -1, 1 2 3. So we can check with the given output that completely matches. And the second test case, like also if we take the second test case also, then we can easily verify that either our assumption is right or our understanding of the questions is right or not wrong. So that is the expected test case. And if we take that like 3, 2, 3, 2, 3, 2, 1, like 3, 2, 1, 3, and 3, 2, 1, 3, 3. And here the case size is 2. If so, till then the array size or the stream size is less than k, we have to turn -1 because there doesn't exist any kth largest element. And but for the second case, the array size or the stream size is equal to k. So we can easily find the kth largest element, that is 2 here, because 3 is the first largest element. The second largest element will be 2. And what will be here, what will be the case for here? Here also, if you see that carefully, that second largest element will also be 2. And here also, if you see carefully, the second largest element will be 3. And we have to consider one case here, as their duplicates allowed. So what does it mean? The 3 to 1 3, if we sort it internally, then 3 3 3 1 2 1. So we can say at the second position 3 comes. So the second largest element will be 3. The first largest element will be 3, and the second largest element will also be 3. So it can possible according to the questions, because if you see the statement of the question, it is given here like not the kth largest unique element. So the 3 can be first largest as well as second largest also. So it happens for that second third test case also, because there is also 1 3, that is 3 3 here. So we have to return that 3 also here. So actually our answer should be -1, 2, 2, double 3. So let me check with that output. Yes, it's completely matches. So our understanding of the questions is completely right. So let's dive into the implementation part. So to implement the questions, we have to first of all we will go to the brute force approach. So the brute force approach will be like that. We can solve it big of n square. So how big of n square? So what the question states? Question states that we after the insertion of each and every element, like for each and every element, like for I in 1 to n, each and every element. So let me write the pseudocode first. For each and every element, we have to check the kth largest element. So how can I find the kth largest element? So to find the kth largest element, what can I do? We can we can find that we can internally sort that element. So we can internally sort till then the sorting will be if you want to sort the whole function, if we want to sort the whole array, then it will be take then it will take then it will take big of I log I. So why I written here I log I? Because I will be sort the array the I will sort the array only the part which is inserted till now. So I am considering that I am at ith index and there are ith elements. So to sort the whole array, we have to need I log I size. So and after that we have to check like the k what is the kth element of that sorted sequence. So then we have to find what kth largest sequence, kth largest element, and we have to sort it, and we have to store it. Sorry, my pardon. We have to store it in array list or vector, whatever it is given according to the questions in an array list or statement or vector. Anything what is given according to the language of the question. If the Java it is Java, then it will be array list, and if it is C++, then it will be vector. So that is the question that then for if we consider the time complexity of this kind of solution, then it will be like summation of summation of I log I, and what will be the limit of and limit of I will be 1 to n. Limit of I will be 1 to n. So it will take approximately like big of n square login solution, like big of n square login solution. That is completely a brute force. Big of n square login solution. Okay. So if we want to optimize this, so then we can optimize it. How we can optimize it? So for that we can take in data structures like that is priority queue. So what priority queue does? Priority queue, after insertion of each and every element, the priority queue sort internally the whole array in big of login time. Then, so what happens? We don't have to sort the whole array each and every times during the insertion of element. And the priority queue has a property. Priority queue, priority queue uh, can insert an element at big of in login time, big of in login time, login time, sorry, login time. So the whole part will be replaced by just login time. Then you can easily check that the big of in square login will be converted to big of login. Like then the time complexity complexity will reduce to big of L log n time. And according to the question is given as it is like n is 10 to the 5. So it is completely fine, like big of n log n, that is approximately 10 to the power 5, 10 to the power 5 log 10 to the power 5. That is approximately, it is round of like 10 to the power 7, 10 to the power 6, or something much about this. So 10 to the power 6 will be the approximate time complexity. That is completely fine because we can take up to 10 to the power 9. So according to the, as I tell the pseudocode, so actually as I write the pseudocode, we will implement the solution. So if you write the pseudocode in the optimized way, then we have to iterate the whole array for I equal to 1 to n. And each and every time, first we have to add that element, like the array of ith element, array of ith element, equal array of I. And after that, we have to check if the array size, we have to check if the priority queue size greater than equal to k. So just we have to pop that element. Because why you have to pop that element? Because if the priority queue size is greater than k, so it means that there exists an element, there exists some element which is not in our concern. Because if we take that solution, if you take the example of the first test cases, when there will be when there will be like 1, 2, 3, 4, 5. So what is the priority queue implementation? Because this is a mini priority queue. So actually in the above there is the smallest element will be there. So 1, 2, 3, 4, 5. So if the kth element, like if the size is more than k, here k is 4, so the answer will be 2, because we don't need 1, because 1 is like more than kth largest element, because it is fifth largest element we can see here. So 1 is not in our concern. So and 1 can never be the in the future the our answer, because if till now the 1 can't be the answer of our, so in the next page also 1 can't be the answer. So we can easily like delete this. So we can easily pop that element. That's why if the priority queue size is greater than k, we can easily pop that. Then I hope this point is clear. And after that, if the priority, after that we have just, it is finished, and we have to now we have to store the answer for that insertion. So what will be the answer? If the priority queue size is less than k, then we can just add -1, because if the priority queue size is less than k, so there doesn't exist sufficient number of elements here to contain like kth largest element, to become kth largest element. But if the priority queue size is equal to k, like it is equal to k, then we can say the kth largest element will be the top of priority queue. So it will be the PQ of pick, like the top of priority queue. Okay. And after this, that is the main code of the question. That is the main code. And after that, we can just easily return the answer. Like it is vector or array list, whatever it is. So that's it. That is written in the code. So this is the code. And the element is array I. As I am told in the video, like in pseudocode, I just have written that, implement that in my Java code. So that is it. I hope this is clear. So thank you.